Hi everyone, I wanted to spend a little bit of time and talk about interactions. So when we're looking at data, it's one of the easiest way to understand interactions is to just look at them. And we want to talk through, in this particular study, I manipulated, and I didn't actually run this study, this is fake data, but let's say that I gave my participants ice cream or mashed potatoes, and these two dishes had either gravy or chocolate sauce on them, and those dishes were served either warm or cold. And so we want to know, is there an effective dish? Is there an effective topping? And is there an effective temperature? And finally, do these variables interact with one another? So let's first start off by defining what a main effect is. A main effect is the effect of one independent variable on the dependent variable. When you look at a main effect, you do not consider the other independent variables. So here in this first graph, this is a giant, so the design of this study would actually be what's called a 2 by 2, so 2 by 2 by 2 design. So what we have here is the first independent variable is ice cream or mashed potatoes, so that has two levels. The second one is gravy versus chocolate sauce. That also has two levels. Sorry, that's this one. And then we've got warm versus cold temperatures. That also has two. And what we're expecting here is that people are going to prefer ice cream most when that ice cream is cold with chocolate sauce on it. On the other hand, they're going to prefer mashed potatoes most when there's gravy on it and when the dish is served warm. So this is kind of a fun example that I think really highlights and makes interactions make sense. So I've actually color coded this graph specifically using blue and red colors. I've also noted here in the warm conditions there are solid outlines, in the cold conditions there are dotted outlines. And I think that this is really important to better understand these interactions because now you can see what it looks like when we collapse across these conditions. So first, I'm interested in understanding, is there a main effective dish? So again, a main effect means that all I care about is the difference between the two dishes, in this case, ice cream versus mashed potatoes. So I'm going to ask you, what do I not care about here? Well, first, I don't care about whether the dish had gravy or chocolate sauce on it. I also do not care about whether the dish was served warm or cold. So what I need to do is I need to take all of the averages of the ice cream bars and I need to take all of the averages of the mashed potato bars. So I'm going to ask you, because I'm going to color code these graphs as I do this, will the bars be red and blue or will they be collapsed and be purple? Will the bars have a solid outline versus a dotted outline or will they be collapsed to have, and in this case I'm going to code it as no outline? So that's kind of how I want you to start thinking about this as we think about these collapsing. So in this first main effect, I'm just asking, is there a difference between the ice cream condition and the mashed potatoes condition? So if I'm thinking about this, well, first I need to collapse all of these red bars together, and I'm just going to take the average. Now in a real study, you might have different numbers of participants in each condition. In that case, you would need to take a weighted average, but for this, we're just working on visualizing main effects and interactions. Let's assume that there's just 30 people per condition. Let's just make that assumption. It's equal across all of these. That makes the collapsing a lot easier so that we don't have to think about that. So we're going to collapse the red bars together here because that signifies ice cream. Then we're going to collapse the blue bars together and that would signify mashed potatoes. I've done that on the next graph here. And so now we need to look, and literally all I did was I took the average here. So I did 2 plus 3 plus 3 plus 9 divided by 4, and that is equal to 4.25. The next one, I took 8 plus 4 plus 5 plus 4 divided by 4, and that gave me an average of 5.25. So again, when we look at a main effect, we do not care at all about the other variables in this data set. All we're asking is there a significant difference between ice cream and mashed potatoes? In this case, the mean from ice cream was 4.25. The mean for mashed potatoes was 5.25. Now, on a 1 to 9 scale, I'm thinking that there's probably not a significant difference here. And the reason that I'm thinking about that is on a 1 to 9 scale, typically the standard deviation is about a 2, is oftentimes about the highest that standard deviation tends to get on a typical Likert type scale. Sometimes it's up to 2.5, but the difference here is a mean difference of 1. So first off, that's greater than a 10% difference on this scale. It's a 1-point difference there. And secondly, if the largest standard deviation that we're thinking about here is about a 2, and again, we don't know what the standard deviation is, we're just taking a guess at this point, but this looks like probably it's going to be roughly half of a standard deviation difference. That's probably going to be a significant effect where we would say mashed potatoes is perceived significantly higher than ice cream in terms of general likability here. And you might disagree with that, and that's fine, but for the purposes of this assignment, we went ahead and said mashed potatoes is higher than ice cream. So now I'm interested, is there a main effect of topping? So now I want you to ask yourself, what do I not care about in this particular one? Because again, I'm only looking at the main effect of topping. So here I'm comparing gravy to chocolate sauce. I do not care about whether it was a warm or a cold temperature. I also don't care about whether it's ice cream or mashed potatoes. So first I want to ask you, should the bars be color-coded as red and blue, or will we collapse to purple? If you said that we'll collapse to purple, you're absolutely right, because I don't care about ice cream versus mashed potatoes right now. So we will be looking at purple bars on the next page. Now I want to ask you, how many bars will there be on the next page? Up here, when we collapsed, there were 2, because all I'm caring about is the difference between ice cream and mashed potatoes. So how many bars will be in the next graph? If you said 2, you're absolutely correct, because all we're comparing here is chocolate sauce to gravy. Now, will I need to code the outlines of these as solid lines versus dotted lines? That's the next question that I'll ask you. So do I care about the difference between warm versus cold? If you said no, you're absolutely correct. I do not care about solid versus dotted. So on the next graph, these should be just purple bars. And lo and behold, that's what they are. So we've got chocolate sauce, and in order to calculate that average, what I did was I took these 2 bars and I averaged them, and I averaged those with these 2 bars. So I took 3 plus 4 plus 9 plus 4, divided that by 4, and that gave me an average of 5 for chocolate sauce. Then I took 2 plus 8 plus 3 plus 5, and then I divided that by 4, and that gave me an average of 4.5 for gravy. Now here, I'm asking you, is there a main effect of topping? I would say probably not. They are different by about half of a scale point, but given again that the standard deviation is typically approaching 2 on a 1 to 9 scale, this is about a quarter of a standard deviation different. If you had a pretty large sample size, maybe this would be significant, but this is probably not going to be a significant difference here. So now let's move on. Now I'm asking, is there a main effect of temperature? So what do we have to do here? What do I care about and what do I not care about? So I don't care about the dish, so that means I'm going to be seeing purple bars on the next page because I'm going to collapse across the red and the blue bars. The next thing that I don't care about is I don't care about whether they got gravy or chocolate sauce right now. All I care about is warm versus cold. And so what I'm going to see on this next page is these 4 bars averaged together. So 2 plus 8 plus 3 plus 4 divided by 4. And then I'm going to see 3 plus 5 plus 9 plus 4 added together and then divided by 4. And so these will be coded as purple bars with a solid outline that signifies warm, and purple bars with a dotted outline that signifies cold. And what we see here is that the average for warm was a 4.25. The average for cold is a 5.25. So then we're going to go on to the next graph, and we're going to see this. And I'm now interested in what's called a two-way interaction. Two-way indicates that there are two variables that are contributing to this interaction. And first off, I'm interested in dish by topping. So the first thing that we need to do is collapse across the variable that is not listed here. So I do care about ice cream versus mashed potatoes. I do care about topping, which is gravy versus chocolate sauce, but I do not care about warm versus cold temperatures. And so what I'm going to do is I'm going to take this 2 and I'm going to average it with this 3. And that's going to tell me the mean of ice cream in the gravy condition, again, not caring about whether it's warm versus cold. Then I'm going to average this 8 with this 5, and that'll give me the mean for mashed potatoes in the gravy condition. And again, I don't care about warm versus cold. Next, I'm going to average this 3 with this 9, and that'll give me the mean for ice cream and chocolate sauce. And then I'm going to average this 4 with this 4, and that'll give me the mean for mashed potatoes and chocolate sauce. And again, I don't care about temperature. So when I do that, I get a graph that looks like this. And what I want you to do, I'm going to delete these circles for just a second. So this is my new graph once I've collapsed across temperature. And you'll see that since I collapsed across temperature, I don't care about whether they're dotted or solid lines. All I care about is ice cream versus mashed potatoes and gravy versus chocolate sauce. Now, when you think about an interaction, what I'm asking you is, does the effect of dish depend on whether participants had gravy on that dish or chocolate sauce on that dish, and vice versa? So the way that you visualize an interaction is I'm going to add these circles back in. I'm going to add these circles back in, and I will fill them with nothing. And I want you to just take a lens. I want you to take a lens here, and I want you to zoom in this circle, and I want you to zoom into this circle. And I want you to look at these two images. Does this left image look like this right image? If you said no, you're absolutely correct. This does not look at all like this. That's when we would say that there's probably an interaction. Because what's happening is when gravy is put on the dish, people much more strongly prefer mashed potatoes to ice cream. However, when there's chocolate sauce on the dish, people much more strongly prefer ice cream to mashed potatoes. This is what we actually call a disordinal interaction. So disordinal interaction, and I'm going to highlight that. And the reason that this is a disordinal interaction is because when participants were given gravy, they preferred mashed potatoes, but then the ordering changed. They did not maintain their ordering. So here, they preferred mashed potatoes to gravy, but over here, they actually preferred ice cream to mashed potatoes. Now, both ordinal and disordinal interactions are interactions, but here we see a crossover. That's what happens with a disordinal interaction. An ordinal interaction would happen if, let's say, this blue bar was like just above this red bar. There'd be a very small difference over here and a very large difference over here. That would still be an interaction, but because the blue bar is always higher than the red bar, it would actually be called an ordinal interaction instead of a disordinal interaction. So again, we're just looking here, does this circle look like this circle? If they do, there's no interaction. If they don't, there's probably an interaction. So let's come back to this overall graph. Next, we want to know, is there a significant dish by temperature interaction? So now I want to ask again, what do you not care about? Here we're looking at dish, so ice cream versus mashed potatoes, and we're looking at temperature, warm versus cold. I do not care about the topping in this case. So I do not care about gravy versus chocolate sauce. I do not care about those. So what I'm going to do is I'm going to calculate the mean for ice cream in the warm condition. So I'm going to collapse this 2 and this 3 together. Then I'm going to look at the mean for mashed potatoes in the warm condition. I'll collapse this 8 and this 4 together. Then I'm going to look at ice cream in the cold condition. I'll collapse this 3 and this 9 together. And then I'm going to look at mashed potatoes in the cold condition. I'll collapse the 5 and the 4 together. And when I do that, if I take those averages, I get a graph that looks like this. So I've got ice cream in the warm condition. I've got mashed potatoes in the warm condition. I've got ice cream in the cold condition. I've got mashed potatoes in the cold condition. So again, the question that I'm going to ask you is, and I'm going to jump this circle back down. Oh, actually, I'll just delete it. I'll create a new circle. Sorry about that. I'm going to draw a circle here. And I'm going to ask you to look in this viewing window. And I want you to tell me, does this viewing window look like this viewing window? If you said no, you're again absolutely correct. We are seeing a significant disordinal interaction once again, such that when participants were given a warm dish, they much preferred mashed potatoes to ice cream, which makes absolute sense. And when they're given a cold dish, they much prefer ice cream to mashed potatoes. And that's what we would call an interaction, because the effective dish does significantly depend on the temperature of that dish. So next, we're interested in the topping by temperature interaction, and I want to ask you what we do here. What do we not care about? We do not care about the dish that people were given. So we don't care about if it's ice cream or mashed potatoes now. So what we're going to do is we're going to collapse across these two bars right here, so 8 and 2, and that'll give us the mean for gravy in the warm temperature. We'll collapse across these two bars right here. That'll give us the mean for chocolate sauce in the warm temperature. Then we've got the mean for gravy in the cold temperature and the mean for chocolate sauce in the cold temperature. Once we do that, and again the bars are purple because I'm collapsing across ice cream versus mashed potatoes. So we're going to come back to those viewing windows. Again, to visualize an interaction, what you're asking yourself is, does this circle, does this viewing window look the same as this viewing window? And if you said no, you're again correct here. What we're seeing is that when participants were given chocolate sauce, they much preferred the cold dish to the warm dish. But then when they were given gravy, and who likes cold gravy? When they were given cold gravy, they actually preferred the warm dish to the cold dish. And this tells us that there is a significant topping by temperature interaction. Again, we're seeing a disordinal interaction here because in the chocolate sauce condition, people preferred the cold dish, but in the gravy condition, people preferred the warm dish. They did not maintain their ordering, causing a disordinal interaction. And again, we know it's an interaction because these two viewing windows do not look the same. The effect of each variable depends on the other variable. And finally, and this is where it gets more complex, I'm not going to go too in detail on three-way interactions. By the time you need to look at three-way interactions, you will probably have a higher level statistical knowledge than you currently do when watching this video, but I do think that you're able at this point to check out this three-way interaction that's happening here. So we're going to ask, is there a three-way interaction between dish, topping, and temperature? This time I care about everything. I care about temperature, I care about dish, I care about topping. And when we think about visualizing a three-way interaction, it's the same way. Up here, remember, we had these viewing windows. I said, does this viewing window look like this viewing window? When we look at a three-way interaction, we look at this white viewing window over here, and we compare it to this blue viewing window over here. Does it look like this window looks like this window? If you said no, you are again correct. It does look like we have a significant three-way interaction here, because what we see on the left side of this graph looks nothing like what we see on the right side. And what this three-way interaction tells us, this tells us a lot of information. It tells us a lot of important information. What this means is that these three variables all depend on one another. When the dish is cold, people really like ice cream with chocolate sauce. And that makes sense. People like putting chocolate sauce on cold ice cream. When the dish is warm, they much prefer mashed potatoes with gravy. That makes sense. No one likes warm ice cream with warm chocolate sauce on it. That's just chocolate milk. I guess people might like that. But for the purposes of this, they don't like that. Instead, what they really like is nice warm mashed potatoes and gravy. And then we've got these other variables, or I mean, we've got these other effects down here. You can kind of parse it out a little bit further, but what this is really telling us is that the only time that people really, really, really like ice cream is when it's cold and has chocolate sauce. The only time that people really, really, really like mashed potatoes and gravy is when it's warm. So this is how we unpack and we think about three-way interactions. We look at the information outside of this blue box. We look at the information inside of this blue box. If those two viewing windows look the same, there's probably, or at least similar, there's probably not a significant three-way interaction. But in this case, these look wildly different. There's more than likely a significant three-way interaction. So I hope that this helped all of you to better understand main effects and interactions. These are complex topics. Oftentimes students, especially students in entry-level statistics classes, really get confused and they find it hard to ignore variables. And that's, I think, the hardest thing for students is whenever I ask, is there, if I come up here and I ask, is there a main effect of dish? People are like, they oftentimes say, yeah, they like ice cream better when there's chocolate sauce. But again, when we're looking at a main effect, we don't care about the topping. And we've got to just break this down. And I think that it's really helpful to think about this in terms of color coding, in terms of, thinking about the outlines of these. It's really, really nice to kind of think and break this down. So I hope that this was helpful. If you do have any questions, please let me know. I love talking about and visualizing data. I love looking at interactions between variables, and I hope that this was helpful for your own learning. So have a great rest of your day. Please let me know if you do have any other questions.